A pure semiconductor is silicon or germanium, free of any impurity, is called intrinsic semiconductor. Let us take, for example, a silicon atom. It makes four covalent bonds with the neighboring silicon atoms using four valence electrons. At 0 Kelvin temperature, this is the structure of a silicon atom. In this, you can see that these electrons make covalent bonds with the neighboring silicon atoms. Now, if we increase the temperature, these electrons get thermally generated, resulting in the breakage of these covalent bonds. And so, the room temperature is sufficient to break some of the covalent bonds and thermally generating some of the electrons, which leaves a positive vacancy at its place, which is known as a hole. Now, what happens when there is a hole? See, if here this electron is thermally generated, then there is a positive charge vacancy. So, another electron from some other site will rush towards this positive charge, creating a vacancy at its position. You can see from this diagram at site 1 this is a hole by due to this excitation of this electron. Now from the site 2 the electron will jump to the this hole and making another hole at its position like in figure 2. So these thermally generated electrons move to the conduction band. The number of these electrons can be increased if we increase the temperature or the thermal energy of the semiconductor. But if we increase the thermal energy or temperature of the semiconductor more often, then the semiconducting properties of the semiconductor will be destroyed over time. So what we will do to overcome this? We started adding impurities to the semiconductor. This process of adding the impurity to the semiconductor is called doping, and the impurities that are added to the semiconductor is called dopants. Now, there are some rules to keep in mind while we do doping. Some of them are that the size of the semiconductor atom should be comparable to the size of the dopant atom, and the dopant atom should always take the position of the semiconductor atom. The crystal lattice of the semiconductor atom should not be destroyed and the concentration of the dopant should not be very high.